target. There's my target, 8 feet wide. The retro reflector on top so I can range find to it. There you be. Right at the left end. Oh, the bloody cows. Hold on. Okay, now that I got the path cleared. Okay, I've got a 8-foot wide styrofoam reflective target out there in the fence, you can see. And I've got this angle measuring gizmo here. I've got it zeroed out to 0 degrees, 0 minutes, and 0 seconds. That's what that is there. It's an old one, so they don't display the seconds and minutes mark, but that's what it is. It's 0 degrees, and the next 2 digits are the minutes, 0 to 59, and the next 2 after that are the seconds, 0 to 59. Excuse the cows. So you can see I've got it zeroed right at the left end of that. And now I'm gonna see if I can hold the camera and slew this over to the right end and zero it right to there. I think that looks pretty good. That gives us an angular width of 1 degree, 21 arc minutes, and 16 arc seconds. In the horizontal, that's why that little LED on there is lit, because that's for the horizontal. Now I'm going to go ahead and measure the distance. (103.095 meters). And that's on the right end, so just for clarity, I will swing this back to the other end and measure the distance there as well. (103.048 meters to the other end. Okay, now to test whether a theodolite with a different focal length or magnification in the telescope measures angles differently, I have switched out to a Pentax ETH120F, which has like a 26, I think, 24 or 26x telescope. The other total station that I just used, the geodimer, whatever, 140, has a 30x telescope. So you can see I have my crosshairs lined up to the left end of that. I've got my horizontal angle set to 0 degrees, and this is reading decimal degrees. I've got this set to read decimal degrees, so that's 0.0000 degrees in the horizontal. And now, let's see if I can slew that over. The sun's in my face. I can hardly see my phone on my screen. Oh, I'm gonna have to put my eye up to this to actually see, because the sun's right in my face. Okay, I have lined the crosshairs up to the other end of that 8-foot thing, and there we have 1.358 degrees. This is the exact same distance as the previous video. I didn't even move the tripod, I just changed out the instrument. To compare another total station, this is a Nikon DTAM 420, and it's on the same tripod. I haven't moved the tripod, just changed out the instrument. Point at the same target there. Got the crosshairs lined up on the left end of that 8-foot plank thing. And can you see the screen? More or less. 337.989 feet and horizontal angle of 0.0000. Now, back to there's the crosshairs. I'm gonna have to put my eye up to the thing to see it. It's just too bright and glary out here to see it on the phone screen. Okay. So you can, I don't know if you can see it or not. I can't really see the phone, but I got the crosshairs lined up good. And now we're at, can you see the screen? Horizontal angle, 1 degree, 21 minutes and 11 seconds. And I could go to XYZ mode. 7.8, that is an 8. That's just the display's got a flaw. Anyway, 7.896 feet in the Z. Oh, the X, I'm sorry. The Z is the height, it's above me. So 7.979 feet, that's like X is to the right. So basically, it's measuring 8 feet. And since I was trying out different theodolites and total stations here, I thought I'd try out another while I still got the tripod set up in the same spot. This is a geotomer, I guess so, whatever, 4400, and as you can see, I've got it zeroed out at, well, that display doesn't show up very good, does it? HA horizontal angle is 0 minutes, 0 seconds, or 0 degrees, 0 minutes, and 0.1 seconds. And I've got it pointed right on this cow's rump. Come on, cow. Hold on. Okay, now that the path is cleared, you can see I've got this zeroed out on the left, and now I'm going to start going oopsie to the right end. I'm going to double check that with my eye. Okay, close enough. It's lined up, and we're reading 1 degree, 21 minutes, and 19 seconds. And this one we can actually maybe go into track mode. Might have to mess with the angles a little bit to get the retro reflector to pick up. There we are. We go down here. That helps. And then okay. See, now it's picking up a reflection. Resight that with my eye. Okay. Got it lined up to the right there. And then we can cycle through to XYZ mode and see the easting, the E, that means to the right, is 7.97 feet. So that's pretty close to the 8 feet. And it's 338.1 feet away. Okay, there's my target out there, that little white line right by my fingertip. And right now I've got the theodolite centered on the little prism on top there. You can't really see it, but it's that round thing right by the crosshairs. And so I'm going to do a measure. It's going to measure the distance with the EDM, the electronic distance measuring. 993 feet, 0.109. And now we take and bring horizontal down, I guess. Move it over. Right, line it up to there. And you can see I already got that set to 0 horizontal angle. Vertical angle just means it's 4 minutes, 12 seconds below us, but we're not using that right now. Now I'm going to swing this over to the right side of the 8-foot thing here. Now I'm going to check that with my eye. Got it lined up. It's just hard to tell through the phone. See, I got it lined up pretty close. And horizontal angle is now 27 minutes, 36 seconds. We can actually put this in XYZ mode. And it is measuring the X size, the width of that, as 7.973 feet. So there you have it. At 993.109 feet, an 8-foot wide target is, or object is 27 minutes, 37 seconds wide. Okay, now I'm doing my nearly 1 kilometer shot down by this here street. And you can see I've got it, the horizontal angle set to 0. I got it lined up on this stoplight here. I'm gonna go over to that stoplight there. Now I can't measure these with my rangefinder because there's not a prism over there on those lights, and I don't want to walk all the way down there and stick one to a post just to have someone rip it off. But the angle to the first stoplight is 16 minutes, 8 seconds. Horizontal angle. I'll just get the distance off of Google Earth. and we'll make the best of it. And the angular distance to the second one is 26 minutes and 1 second. And there you have it.